mixture. So, retention factor or retardation factor. How are you going to calculate it? Retardation factor or retention factor is equal to the distance migrated by an analyte over the distance migrated by the solvent. So let's suppose that this is the spot that I have spotted in the beginning of the development, and after the development the spot has migrated into this position. Okay, if you want to calculate the retardation factor or the retention factor for this spot, what we're going to do is measure the distance from the starting line till the center of the spot. Okay, and this is the distance moved by the analyte, and then divide this distance by the distance migrated by the mobile phase, and the mobile phase, the distance that it has migrated, is measured from the solvent front till the starting line, this distance. Again, in order to calculate the retention factor, you will have to measure from the center of the spot till the starting line. This is the distance migrated by the analyte, and the distance migrated by the solvent is measured from the starting line till the solvent front. That's why it's very important to mark the solvent front, and it's very important that you spot while spotting. Using the capillary, you have to spot in very brief touches a very small amount of the solution, so that the final look of the spot is circular and symmetric. Okay, this is an ideal spot. RF value is the ratio of the migration distance of the compound of interest to the mobile phase front. The retardation factor is characteristic for each compound. Each compound will have a specific RF value when it is used in a specific chromatographic system, which means here it means the mobile phase is the same. So if the mobile phase is the same, then the compound should have the same RF value. Okay, the application of TLC, as we have said before, it is used in pharmacopoeias to identify the spots and to determine whether the solutions are pure or impure. This experiment, you will not do it practically, it's just for your information. You can apply the previous TLC procedure using standard paracetamol, for example, a drug, and an unknown solution. This experiment is done to determine the purity and the identity of the unknown sample. Okay, let's see. So if this is the standard paracetamol, okay, after development it yields only one spot, and the unknown has yielded 2 spots. This means that there are 2 compounds, not only one, 2 compounds in this solution, one of which is paracetamol. Why? Because this spot has the same RF value, or it has migrated the same distance as paracetamol. That's why we can conclude that this solution contains paracetamol, but it is impure as it contains another compound other than paracetamol. Okay, let's move to the other plate. This is standard paracetamol and this is the unknown. The unknown has yielded only one spot which has the same RF value as paracetamol, and that's why we can conclude that it contains paracetamol. And it is pure as it has yielded only one spot. Okay, let's move on to the next TLC plate. Standard paracetamol, only one spot. The unknown has yielded 2 spots. 2 spots, this means that it's impure. Okay, what about the identity? Is it paracetamol? Does it contain paracetamol? No. Why? Because none of these spots has the same RF value as paracetamol. One has moved further and one has moved lesser. Okay, so no paracetamol in this unknown solution. And the final example, this is standard paracetamol and this is the unknown solution. So the question is it pure? Yes, because only one spot here. Does it contain paracetamol? No, again, it does not contain paracetamol because this spot has a lower RF value than the other spot or the paracetamol. Different RF values, this means that this is not paracetamol. Okay. So some of the questions that might pop in your heads is that why must the spot be applied to the TLC plate above the level of development of the solvent? Why? Because if you apply the spot under the level of the development of the solvent, the dyes will dissolve in the mobile phase and it will never be eluted. So that's why the level of the starting line should be above the level of the solvent, so that the solvent will move up to the dyes and not the other way around. Okay, so the level of the spot or the starting line should be above the level of the development solvent, so that the solvent will move and take with it the dyes, and to prevent the dissolution of the dyes in the mobile phase. Second question is, what will be the result of adding too much sample large spot? As I've said before, adding a large spot means that the sample or the spot after development will look tailed. It will look like really big. It will not look symmetric or circular. It will look tailed. Okay, so this is the section for today. I hope that you have understood it, and thank you.